happy to see you again. I hope things are going well. We're getting together today to work on Math 7-4. 7-4, so get your math worksheet 7-4 and your student workbook. Turn to page 291. 291. Pause this video for a second so you can get all your materials ready. You'll need a pencil, your workbook, and your homework sheet. Okie dokie. Do we have it all? Okay, let's get started. So today we're talking about patterns and expressions. We're talking about patterns in numbers, which is kind of fun. I love to find patterns in things, games that have patterns and such. So this is a really cool lesson and I'm excited for it. All right, so you're turning to 291 in your student workbook. It looks like this. Okay, and we're going to start right up here at the top, and we'll work together a little bit here. It says a numerical pattern is a sequence of numbers that share a relationship. Okay. Each number in a numerical pattern is a term. Okay, so if we are looking at the first 5 numbers in this pattern, each one of those numbers is considered a term. So we've got the first 5 terms in this sequence. The first term, second term, third term. We're showing all 5 terms in this sequence. The pattern above starts with a 3, and then each term is 2 more than the previous term. So we're going to find 2 things as we go along looking at these patterns. We're going to give the first term, so we're going to say it starts with this, and then we're also going to give a rule for how we get to the following terms after that. Okay, so we're finding the first term, we're going to say what that is. The first term in this case is a 3. And then we're going to find the relationship that that has with the following numbers that go after that. Okie dokie? Okay. So looking at our workbooks, we have our sequence of numbers right here, right? Our terms. It goes 3, 5, 7, 9, 11. Now some of you might say, well, we're counting by 2s. True, we are counting by 2s. Some of you might say, well, those are all odd numbers. That is true as well. But we are just concentrating on the numbers that have been given to us. So what we need to say is, okay, laundry is done. What we need to say is, this set of terms starts with a 3. And then we will add 2 each time. The pattern above starts with 3, and then each term is 2 more than the previous term. Yep. You can write numerical expressions for the terms. Okay, so let's take a look down. We're looking at just the examples down below. It's those numbers that are in red. Okay, so we start with the 3, and I just want you to look at the top row of the red numbers right now, just the top row, okay? We start with the 3, then the next number is a 5. So we're going to say that that looks like a 3 plus 2, correct? Since our first number is 3, we're always going to start with that to kind of explain what the relationship is. So we're always going to start with 3 plus something in this case. So we've got 3 plus 2 is the 5. Then we look at this next one with term, which is 7. That would be 3 plus 2 plus 2. Yep. The 9, 3 plus 2 plus 2 plus 2. And then the 11 would be 3 plus 2 plus 2 plus 2 plus 2. Okay, so it's telling us each time in each of those terms that we start with 3 and then we add 2, depending on which term we're talking about. Now, let's take a look at the next row of red numbers. Okay, so we're looking right here. Okie dokie. Okay, so you can follow along in your book. Another way to show these terms are expressions. And here's another way. We've got some parentheses in here, but we've been talking about expressions. In fact, that's what we did for 7.3, right? We plugged in a value of a variable and solved our expressions. So it's kind of what we're doing today, only we're just finding these number patterns. So it's kind of cool. Okay, so our second row of our red numbers, we have 3 plus 1 times 2, which is the same as 3 plus 2, right? The red numbers that are just above that. Yeah, 3 plus 1 times 2 is the same. 3 times 1 times 2, the parentheses tell us to do 1 times 2 first. 1 times 2 is 2, and 3 plus 2 is 5. So that's describing that second term of our sequence. Okay, jump to the next one. We have 3 plus 2 times 2. 2 times 2 is 4. 3 plus 4 is 7. So that is the third term in our sequence. Then we have 9. It's 3 plus 3 times 2. 3 times 2 is 6. Plus that 3, that's 9. And then you can look at the 11, which is the fifth term in that sequence. 3 plus 4 times 2, right? Because we had 2 plus 2 plus 2 plus 2. Yep, there's 4 2s. That would be 4 times 2. And then we add that 3 that we started with. Let's see if we can do a little bit together here. So let's look at number 1A. It says write 2 expressions for the next term, the 6th term. Okay, so these are the same numbers that we've been working with, right? Okay, I bet you can guess what the next term is. Just think about it right now. What would be the next term after 11? If you said 13, then you're correct. Good job. But now we have to show, oh, well, that's B right there. That's B. So why don't you write 13 at B? Right here, B, you're going to write 13. Okay, but let's figure out how we're going to write our expression for that. We're going to write it 2 different ways, just like they did up in the example. There's those 2 red lines, and we're going to write them each way as well. Okay, so the first one says that we have 3, because we start that whole line with a 3, plus, how many 2's should we put? Did you say 5? I hope you said 5. We're going to put 3 plus 2, plus 2, plus 2, plus 2, plus 2. Let's see if we can write this up here. Okay, so 3 plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 2 is 11, plus 2 is 13. That's what we needed, right? Okay, so that's one way. Make sure you write that for 1A. Okay, now let's write it the other way. We're going to write 3 plus, okay, and in parentheses, we're going to say something times 2, right? We've got 2's here. Something times 2. How many 2's do we have? Count them up. 1, 2, 3, 4, 5. So we've got 3 plus 5 times 2. And let's just double check. 5 times 2 is 10, plus 3 is 13, and we said that our last term would be 13. We could kind of tell by looking at this one. We won't always be able to tell, though. We'll sometimes have to use a setup like this to figure out what the next term will be. Okay, so we've got 1A and 1B. I'm going to have you try something on your own a little bit here. Let's look at number 2. You can do this. Number 2 says, write the first 5 terms of a numerical pattern that begins with 5 and then adds 5. It begins with 5. So 5 is going to be your first term. You can write that one down. You already know. And then the consecutive terms are adding 5. Write it down. Pause this video for just a moment while you write it down. Okay, so we said that it had to start with 5, right? And it says that we have to write the first 5 terms, and that each time we're going to add 5. So basically, we're just counting by 5s, right? We're going to add 5 each time. I start with 5. It's going to go 5, 10, 15, 20, 25. That's some crazy writing right there. Okay, is that what you got? I hope that's what you got. If you didn't, think about what you were missing, and now that you can see the answer, see if that makes sense for you. Okie dokie? Okay, now let's see if we can write an expression. This is 2B. Write an expression for the 6th term of the pattern. We're going to write it 2 ways. Yeah, we are, baby. The first way is that adding way, okay? So we had 5 terms, and it said that each time we added 5. So we're going to go like this. 5 plus 5 plus 5 plus 5 plus 5. So we've got 5 5s, right? So that's the first way that we could write it. Think about how we could write the next way. Think about expressions. Ooh, and you know what? Actually, I missed it. This is for the 6th term. So I only wrote 5. And if I have to know what the 6th term is, then I've got to put another 5 on there because I need 6. 1, 2, 3, 4, 5, 6. Okay. And if I'm going to write an expression for the 6th term, another type of expression, we could write 5. You think about it. You finish this out for me. I'm going to give you a second. Pause the video. See if you can write it another way. Okay. Let's see. Did you get 5 plus 5 times 5? Is that what you got? I hope so. Because we started out with 5. Our original one, it said 5 terms. Okay. So we had 1, 2, 3, 4, 5. Then we added a 6th term. So we had 5 times 5. And we wanted to find out what the 6th term is. So it's 5 plus 5 times 5. Okay, hopefully you're still with me. Okay, I would like you to do 3A on your own. You're going to pause the video, 3A and 3B. Try them on your own, pause the video. 3A says, write the first 5 terms of a numerical pattern that begins with 1 and then ends with 9. Okay, so hopefully you haven't paused it yet. I said 2, but I want to give you a little instruction first. You have to think about what your pattern is going to be. It has to make sense, okay? It starts with a 1 and ends with a 9. Only 5 terms in there. All right, so you have to kind of do a little detective work. Figure it out, pause your video, tell me what you get. Ooh. Okay, friends, come back to me. Come back to me. I think my instructions were a little bit wrong. It says to... I'm so sorry. Whew. Mrs. Norman makes mistakes, and I'm sorry. Sometimes I get going a little bit too fast, and I need to slow down and read the instructions a little bit better. It says that this numerical pattern begins with 1 and then adds 9, and I said that it ended with 9. It doesn't. It adds 9 each time. It adds 9 each time. Okay, so if that changes things for you now, go back and try that again. Sorry. All right. right, let's check it. If we start with 1, okay, ooh, that's crookedy. Goodness gracious, Mrs. Norman. And then we add 9. Oh, what if I went like that? That'd be right? No, because that actually only added 8. 1 plus 8 is 9, but it's telling us we have to add 9 every time. So 1 plus 9 is 10. Right? Okay, plus 9 is 19. Plus 9 is 28. Plus 9 is 37. All right, did you get that? Okay, I hope so. You guys are doing well. Okie dokie, now we have to show our 2 ways that we can show these as expressions. Yeah? Okay, so I'm going to just keep it on this same board. Ooh, don't leave me. Okay. The first one we can do is 1 plus, because we start with 1, right? We're showing what we start with. And then what did we add each time? 9. Okay, and we have 1, 2, 3, 4. And it's telling us that we're finding this for the 6th term. For the 6th term. So I could do it by doing 1 plus 9, plus 9, plus 9. So far I've got 1, 2, 3, 4 terms. Plus 9, that's 5 terms. Plus 9 is 6 terms. That's how I could show what my 6th term should be. Okay, think about the other way that we could show it. Remember, we're going to start with our first term, so I've got 1 plus. How many 9s do I have? Count them up. 1, 2, 3, 4, 5. So I've got 5 times 9. And there's my next expression. 1 plus 5 times 9. That's how we show what that pattern is. Okay. If I wanted to know the 9th term, I could do 1 plus 8 times 9. That would give me the 9th term, right? Because I have 1 term right here and then 8 terms right here. So that would be a total of 9. That would show my 9th term. I could know what my 100th term is in this particular sequence, right? Couldn't I? Yeah, I could know the 100th term. I'm going to write it, squeeze it into the bottom. 1 plus 99 times 9. That would be my 100th term. So I could find any term in my sequence just by using this expression. Kind of cool, right? I thought you would think so. Okie dokie, friends. You're doing great. So let's move on. We're going to turn our page. We're going to go to page 292 in our workbooks. 292. So I'll change that on our board. I'm going to give you a minute to turn it. Let's practice a little bit here. Number 4 says, write the first 5 terms of a pattern that begins with 2 and then adds 2. Begins with 2 and then adds 2. Go ahead and write them down. Your pattern's going to start with a 2 and then it adds 2 every time. You can do this. I know you can. We're counting by 2s, right? You got it? Okay, so it should look like 2, 4, 6, 8, 10, correct? So hopefully you wrote that in your book. This is 4A. 2, 4, 6, 8, 10. Okay. So that's on that top row of those little blue spaces. You got it? Okay. Let's look at B then. We've got 4B. Write the first 5 terms of a pattern that begins with 4 and then adds 4. It begins with 4 and then adds 4 each time. Will you try it out, please? You can pause it. 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20. Okay, so we've got our terms. Good job. Now, C says, circle the corresponding pairs of terms in the patterns. Pairs means 2, right? And they're corresponding. So what we're doing is actually circling the ones that are on top of each other. So let's go like this. Will you try that on your paper, please? Okay. How does each term in the top pattern compare with the corresponding term in the bottom pattern? Ooh, okay, so my top I've got a 2, my bottom I've got a 4. Well, let's see. 2 plus 2 is 4. Let's look at the next one. 4 and an 8. 4 plus 2 is not 8. So let's go back. Let's try and think about it another way. 2 times 2 is 4. 4 times 2 is 8. Huh, maybe this might work. 6 times 2 is 12. 8 times 2 is 16. 10 times 2 is 20. Aha, I see a pattern between these two lines. If I double the top line, I get the bottom line, right? If I times the top line by 2, I get the bottom line. Okay, awesome. How can we write that out? Well, first, let's figure out. It says to just tell what the pattern is. So for C, that's what we could write, right? The top term is the bottom term divided by 2, or the bottom line is the top line doubled. You write it however you want to, but what we're saying is that if we times the top line by 2, that's what we get for the bottom line. Whether it's doubled, or we could say we divide this line by 2 to get this line. However you want to write it, put it down for C. Oh, it's telling us that we have to do, how does the term in the top pattern compare with the corresponding term in the bottom pattern? Well, the top term is the bottom term divided by 2. And then if you look at 4D, then we can say, well, the bottom term is double term, the top term. I hope that makes sense. I kind of didn't explain that one very well, but C and D are very closely related. They're just saying, okay, the top, or C is saying, we're just being confusing. Hopefully you can just see the pattern that's in this. Okay, let's move on. No worries. I would like you to try number 5 on your own, okay? So, be a little detective here. You got to take the clues and figure out the pattern, right? Okay, so 5A says, write the first 5 terms of a pattern that begins with 9 and then adds 9. Okay? We kind of did that one already, didn't we, for another one? Okay, so you should be okay on this one. So go ahead and do that. You can pause this for a minute while you write it out. 1. It starts with an O. We started with 1 last time. We're starting with 9 this time. So start with 9 and then add 9 each time. Okay, go ahead. I think we got it. You're taking a minute to do it? Okay, now let me show you what I got. I started with 9 and added 9 each time, and it said how many? 1, 2, 3, 4, 5. So 9, 18, 27, 36, 45. There we go. Okay. Then the next one says, write the first 5 terms of a pattern that begins with 3 and then adds 3. Begins with 3 and adds 3. Go ahead and fill those in. I wish I could have you guys just shouting through. We might change our lessons so that they can be a little more interactive. I gotta work something out because this is boring. I need your input. We got 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, and plus 3 is 15. Got it? I hope that's what you put too. Okay. Now, B says, write the first 5 terms of, that's what we did. C says, circle the corresponding pairs of terms in the patterns. Okay, so we're going to circle them like we did last time. Okay. Now, see if you can figure out what the pattern is. What's the relationship between the top line and the bottom line? What do you think? Here I go from 9 to 3. Here I go from 18 to 6. What's happening in each of those that's the same? 27 to 9. I'm dividing by 3, right? Yeah. So if I'm looking at my top line and I compare it to the bottom line, 9 divided by 3 equals 3. 18 divided by 3 is 6. 27 divided by 3 is 9. 36 divided by 3 is 12. 45 divided by 3 is 15. If I look at it from the bottom row compared to the top row, then I would say 3 times 3 equals 9. 6 times 3 equals 18. 9 times 3 is 27, and so on. Okay? Good. I hope you could pick out that pattern. Good job. Okay, so that's all we're going to do in our workbook right now. Page 293 talks about real-world patterns. Same kind of thing. So peek over at page 293. The first one is talking about overdue late fees. So the first line indicates the number of days that are late, that the books might be late, and then the late fee. So on day 1, it's 15 cents. On day 2, it's 30 cents. Fill in the rest. What are we doing each time? We're adding 15 cents, right? Each day that those books are late, we're adding another 15 cents to the fee. Okay, so you should have for number 3, 45 cents. For the day 4, 60 cents. Day 5, 75 cents. Okay, hopefully you got that. And then if we describe the relationship between the corresponding terms, we could say it's the number of days late times 15, right? If it's 1 day late, it's only 15 cents. That's 1 times 15. If it's 2 days late, then it would be 2 days times 15 cents. 2 times 15 is 30 cents. If it's 3 days late, then we would do 3 times 15. 3 times 15 is 45, so it would be 45 cents. You with me? Okay. Well, that's all we're going to do together right now. This video is long enough. Thank you for watching. Love you guys so much. I'm missing you a ton. I would like you to try to do page... No, that's not in your workbook. It's your homework. Let me check this book. Yes, we're looking at Math 7-4. Okay, those are all the things that we've done. There's only 4 problems on here. You got this. Of course, there is like an A, B, C, and D, but I think you'll be just fine. It's just everything that we've done together. If you need to rewind this video and watch some parts over to see how I did on here, you definitely can, to help you work on 7-4. Okay? If you have any questions, you can email me, you can leave a comment. I'm checking those all day, every day. So hopefully I can help you out. Okie dokie. Talk to you later.